Hello, my name is John Wansnyder. I am the city engineer and the public works director for the city of Dyersville, Iowa. Dyersville is where the Field of Dreams is located. And this week we are celebrating National Public Works Week with our own little Dyersville Public Works Week. And we had a number of events. We had kind of an expo for the water and wastewater department on Tuesday of this week, May 17th, 2022. And then we had a presentation on our city's water and wastewater system that evening. However, the recording did not take, so I am recording from my office, which I've changed into a recording studio just for this purpose. So we're going to go through the presentation. So this year we decided to feature our water and wastewater divisions. A few years ago we featured the streets department. That was prior to the pandemic. And so what I want to talk about here is the city's water system and the city's wastewater system. So two questions on your screen there. Where does Dyersville's drinking water come from? Second question, where does it go when we are done with it? Not just water, but other things as well. So first question, where does Starzos drinking water come from? So drinking water for a community, generally speaking, there are 4 steps to getting it to your house. And maybe there's more with some, less with others, but in Dyersville, 4 steps. First step is the source. That's literally where the water comes from. So we're going to talk about that. Step 2 is the treatment. That's just essentially making the water better for use. Step 3 is the storage. We need to have tanks so that we keep the water until you need it. And then the 4th step is distribution, actually getting it to your house. So we're going to first talk about the source. In Dyersville, our public water comes from 2 deep wells. You can see this well here on the northwest part of the state, or excuse me, part of the city, and then on the southeast part of the city. Some communities get water from a river, a nearby river or lake or reservoir. Dyersville gets our water from deep wells. So we're going to just take a look at our well 4. That's the well that's in the northwest corner of the city. It's dubbed well 4. We actually, wells 1, 2, and 3 were abandoned, long ago, and we're using 4 and 5 right now. So a well is essentially a pipe that extends down through layers of earth, layers of rock, all the way to what's called an aquifer. An aquifer is just a known rock formation that has water that's suitable for use. This well is approximately 1,800 feet deep. And so this pipe goes down, doesn't quite go that far, but it goes down enough to get to the aquifer, and then we can derive the water from that. The other well is about the same depth as well, the same size. You can see I've got my little Yeti cup in front of that. That's a good sized pipe there. Yeah, let's see what I was going to say about that. So these are deep wells, as you can see, and we've got a pump set down there, and then piping that comes up from that. And so we pump the water up so that we can use it. This is just another shot of the well 4 site. You can see the well is right here. This building here has our treatment facility. This is one of our storage tanks. This is a ground level storage tank that holds 750,000 gallons. And then this building back here is a pumping system that pumps into the distribution system. So essentially all 4 steps are kind of shown in this photo. So the second step is the treatment part. Again, we want to make the water better for use. This is another shot of the same site. And this building on the left, you can see there's a structure on the top, and then there's a tank here. And what this is a treatment process that allows us to make the water better. This actually removes radium from the water or reduces it. It does it through a water softening process. Here's a shot from inside the same tank that extends up through the roof. And we add substances to this, and then reaction takes place. We filter it out, and the result is we've got improved water. So third step, we need to find a place to store the water, because we can't just send it off to you. We've got to have a place to store it so it's ready for when you need it. Excuse me. So I mentioned the storage tank, 750,000 gallons. This is on the northwest part of town. So that's the well 4. At well 5, we actually have an elevated storage tank, also known as a water tower. Looks like this. This tank holds 500,000 gallons. The tank is elevated 180 feet. And this is what it looks like on the inside. It's a very interesting experience if you go inside a water tower like this and make some loud noises. The echoes in there are very bizarre. And so anyway, if you have an opportunity to experience that, I think you would enjoy it. I do want to say real quick, the reason the water tank is elevated is to provide the pressure in the system. So that water level is actually what provides the pressure all the way to your house. When you open your faucet, you're opening a direct channel all the way to that water tower. And the reason you have water that comes out fast under pressure is because of that elevation difference from the water tower. This shows a shot of next to the water tower, and we have this is a new facility that we constructed recently called a booster station. And see, what happened is we had houses being built in areas that were higher, that were able to be served by the water tower. We also have other existing homes in that area that are higher, too high to be served, to provide adequate pressure from the water tower. And that can happen. You know, you get the water tower can only take care of a certain range of elevation. Once you get above that, you need to do something more. So we constructed this water booster station, and it's not just for houses in that subdivision, but this is going to allow us to grow further into that direction of town, and again, to be able to serve some of those existing homes as well. This is what it looks like inside, just a series of pumps. We've got some storage tanks that are out of the picture that provide for storage as well. So, okay, so we've talked about the source, deep wells that we have. We talked about treatment. We talked about storage. Now the fourth area is distribution. And so, you know, here again, we're showing our wells in the northwest, southeast side of town. We've got water mains that connect those wells and connect to all the houses and businesses within the city of Dyersville, excuse me, generally speaking. And so these water mains are underneath the streets. This is actually a view from inside the booster station at well 4. So we actually, because well 4 is a ground storage tank, that was that first tank I showed you, the 750,000 gallon tank, that because it's not elevated, it's not providing the pressure that we need. And so we have to do that through these series of pumps. These pumps provide the pressure, and that pressure matches the pressure from the water tower. As a matter of fact, we're able to get water out of well 4, pump it through the grid, through the system, pump it up, and fill that water tower from the station. This is just another view of it. You can see over here is where the water comes in from the well, and then it can go out or come in from the tank. I'm not sure if I might have those confused. I think maybe this is the well. Comes into the system. We've got the pumping system. Right here, it goes out into the distribution system, into your distribution network, and then eventually to your house. Just a shot of some water main being constructed. We are actually in the process of extending water main and sanitary sewer to the Field of Dreams movie site, you know, 2.5 miles east of town. Here's a shot of what it looks like going in the ground, just, you know, just kind of a quick shot. That's a 12-inch pipe on the left, a 4-inch pipe on the right. excuse me. Here we're putting together a fire hydrant. That's what a fire hydrant looks like underground. The black part and the part that's encased in the bag, that's underground. So that's what a fire hydrant looks like. This is just a picture of a 12-inch main being connected to a water valve that's going to be also going in the ground. Okay. Once again, the pipes, you know, they go from the distribution center, from the pumping station, from the water tower into the grid. How do they get to your house? Well, this kind of shows the street and the water main in the street. And then you have a connection to that. It's called a water service line that extends underground over into your house. There's a shut off, called a curb stop, excuse me, at the street. Sorry, my voice was gone 3 weeks ago, and it's not 100% yet. And then it goes into your house, and that's where you have a water meter so that we can measure how much water you use. And then eventually it gets to your sink, and you have pure, clean, good tasting drinking water. So I won't ask if you have any questions because there's no way you can answer them or ask those. Excuse me. Second question we had, where does the water and other things go to when we are done with it? So we're going to talk about that. There are 2 steps to that process, essentially. The first step is we need to collect it all, gather it together, all right? And then the second step is we need to treat it. We need to turn it back into good water. So we're going to talk about that. First of all, the collection system. You may recognize what this is. Yes, it is a toilet. There are certain things that we're allowed to flush down toilets and certain things that we're not allowed to flush down toilets. I like to use this chart to kind of help us with that. The 3 P's. You can flush pee, you can flush poo, and then you can flush toilet paper. Those are really the only 3 things we're allowed to flush. Don't flush cigarettes or medications. People talk about flushable wipes. There really is no such thing as flushable wipes. I would encourage you not to flush flushable wipes. Candy wrappers, Q-tips, all this stuff, and other stuff. Once again, 3 P's, pee, poo, and toilet paper, and you will have a happy wastewater collection system. All right, so not just from the toilet, but from bathtubs, from sinks, from your dishwasher, from your clothes washer, all that goes in to your sewer service line, essentially. So it comes from your house into a pipe. That smaller pipe goes into a larger pipe system. You have manholes, you have sewer mains, and this is what that looks like in the city of Dyersville. Again, all over town, under the streets, we've got sanitary sewer collection mains. And the difference between a water system and a sewer system, obviously there are plenty of differences, but you remember a water system is under pressure. You've got that water tower providing pressure. So those pipes are full of water. You open a faucet, it comes out fast. Okay. The sewer system is different. It's operated on a gravity basis. So it's just flowing downhill. It's a lot like a storm sewer system. When the rain comes, it goes into intakes and then it flows downhill through the pipes until it eventually gets to rivers. And those pipes are generally not full. It's, they're partially full. A sanitary sewer system works the same way. You flush the toilet, it flows downhill through that pipe. The last slide I had, through this pipe, downhill, and then it goes into the sewer. It continues to flow downhill through the system. You'll notice on the left side of the screen, southwest part of town, this is our 20 West Industrial Park. It's kind of an isolated system all by itself. All right, so sewage here flows downhill to this southmost point. What we have there is a pumping station. So we have those throughout town. Once you get to the lowest point, you have to lift it up somewhere else, and then it goes into another manhole or system, and then continues to flow downhill, eventually making it to the wastewater treatment plant. So this next slide just shows In the lighter green color, those are called force mains, or pressure mains. Essentially, it's not very high pressure, but that's where and then these red dots are pump stations. So it flows to a low point, we pump it up to another high point, it flows again to a low point, and we have those all over town. So that's how a sewer system works. Pumping station looks something like this. This is actually in Dyersville, on the south end of West Side Park. I'm sure you've probably seen this sitting there. This is one of our wastewater pumping stations. This intercepts the flow from the Bear Creek interceptor sewer. Interceptor sewer is just a large sewer that gathers lots from various directions. That sewer goes all the way up to Farm Tech up on the hill near Highway 20. And so all that flows down into this pumping station, then we pump it uphill to get to another place. Okay, the second part is the treatment part. We want to turn the water back into good water. So turn the wastewater back into good water. So our Dyersville's wastewater treatment plant is located on the south end of town, right near these two pump stations. And a close-up view, this is what it looks like. Okay, and so we're going to talk about what this is, what each of these systems are, and how they function, how they work. So first of all, you notice this pump station, that's there to pump the wastewater up to the top of the hill, the top of the process, into what we call the headworks building, where the treatment system starts. So this is just a shot of that pumping station. All right, so there are 4 steps to the treatment process. All right, step number 1 is called primary treatment. Essentially, we're just removing the trash, removing the grit, and we'll talk about that and what that means. Step 2 is the secondary treatment process. That's where we're feeding the bugs, feeding bacteria to break the strength in the wastewater down and get rid of the what I call the strength of the wastewater. Step 3 is the final treatment. Here we're just cleaning the water. We're allowing the solids to settle, and then we're left with clear water. And then step 4 is a disinfection. There we're removing the bad bugs that are still left in the water before we can send it off to the river. So once again, starting with the first step, the primary treatment, removal of the trash and grit. This is just a shot of inside our headworks building. And this is a bar screen that grabs onto trash. And what I mean by trash is the stuff that people aren't supposed to throw in or flush, like we talked about earlier. So some of that stuff gets in, and we've got to grab it, and because we can't treat it, we've got to grab it and get it out of the wastewater stream. So this traps that, as an auger, brings it up, dumps it into this dumpster. Then that dumpster goes out, they come and get that and take it to a landfill. Dumpster never gets full, but about every 2 weeks we empty it. And so that's removing part of it, the trash. The second part is the grit. We want to remove the grit. That's like sand particles, eggshells. It's the solid stuff that'll settle out to the bottom. We want to get that out. And so we have this large tank, water's flowing around there, and then the grit is settling out, and we're separating that from the wastewater stream. And just going back, you can see there's a dumpster on the left here. That's where that goes. There's a separate machine that takes the grit out, dumps it into this dumpster. Once again, every 2 weeks, these get emptied. It never gets full either. So not a huge contribution to the landfill system, but we're pulling out the trash and the grit with that first step. All right. Second step, secondary treatment, is what I call feeding the bugs. And so this is a shot of they call this an oxidation ditch system. There are a number of different ways to do this. Essentially what we're doing is we're providing an environment where the bacteria can thrive, so it can break down and eat up all the strength of the wastewater. It can eat that up. And so the way that we do it in our oxidation ditch is we've got these large rotors they're like large paddle wheels. They're turning quickly enough to stir the water up, and they're mixing oxygen into the water. The bugs need oxygen. That's the environment they're looking for. They're getting that oxygen. They're thriving. They're munching, having a meal of the wastewater, and it's awesome because we're just harnessing the natural provisions that God has given us, and we're making use of that. And it's really cool to think about that. And we just kind of, you know, put it in high gear, so to speak, to break that down. The third step, so that's the second step, secondary treatment. We're feeding the bugs. And this oxidation ditch is kind of like a large racetrack, and the water comes in at one point, and then it goes through this whole system. We've got openings that lead it to the next and to the next. So it's getting a complete treatment there. So next step is what we call the final treatment. This is the clarification step. We're going to clean the water. So once again, this picture here, you've got our oxidation ditch in the foreground. The background, underneath this roof, we have our clarifiers. And so we'll just go in there and look at what one of those looks like. So basically a large circular tank. It's like 25 feet deep, conical bottom. What's happening here is the water sits there, and it comes in the middle, and then it slowly makes its way to the outer part. And then this here, the skimmer system here, slowly goes around and skims the stuff on the surface. That's called scum. That's literally a technical term in wastewater treatment. And so we're moving the scum and then picking up, dumping it into here, sending that back for treatment. And then at the bottom, what's happening here is all the solids from the bacteria. So it's like dead bacteria or bacteria poop, essentially. So the bacteria has munched the water, and they've taken the strength out of the wastewater, and then they're settling out. We actually add something to kind of help them to settle out. And then they're going to the bottom. And what you're left with is very clear water coming out here. Comes through this weir system, and then it goes out, and that's clear water. It's cleanish water. Wouldn't drink it, but it's cleanish water. All right. We'll come back and talk about where the solids go later. Right now, we're just talking about the clean water coming out. Step 4 for that clean water, cleanish water, is the disinfection step. Now we've got to get rid of the bad bugs that are in the wastewater. And so we do that through a ultraviolet system. I don't know if you can see this. There's actually ultraviolet lights in there. We're sending the wastewater down through these. We've got a series of ultraviolet lights. And what that does is the bacteria exposed to that doesn't kill the bacteria. What it does is it makes it so that they can no longer reproduce. And so the bacteria just die off and they're done. Oops, I went the wrong way. And then this just, provides the depth for it. And then it kind of makes its way out. And then we have disinfected water, and we send that out to the North Fork Maquoketa River. Here's a close-up, and this is clear, cleanish water going out to the river. Now, I'm not going to say it's drinkable water, but that river water isn't drinkable either. What I will say is this water can sustain the life that the river can sustain. So, and we test that on a regular basis. We actually send it down to the Iowa DNR, and they put a bunch of series of different fish in it, and they make sure that it's being treated properly. So one thing I didn't say is we have a system where we recycle the effluent. So that's the clean water. We recycle that, and then we make use of it. So on Friday, I happened to be down at the plant taking these pictures. Number of the operators were doing some cleaning. They were using a hose, different things. Well, that hose to clean things off, and that hose was using recycled water rather than using our clean potable water. We make use of that wastewater effluent, which is clean enough to use for cleaning. I will say this takes a lot of talent and expertise and experience to know how to operate a water system, a wastewater system. And in Dyersville, we've got operators that are second to none. So, excuse me. Wow. Okay, there is one more thing to talk about. So I mentioned back here in this tank that, you know, the clean water goes out, but there is solids that settle on the bottom, and we've got to deal with that. So that's called solids handling. And so what we do is we send that off to these other large tanks. These are called digesters, and we put the sludge in there. That's the technical term for those solids. It's called sludge. Send it there. We further treat it, add oxygen, and then stabilize that even more. And then eventually we send it off. Whoops, I went the wrong way again. Eventually we send it off to this other building beyond the tank there. And then what we're doing is we're trying to squeeze the water out of it so that it's much less volume, easier to deal with. And so this is called a belt filter press. And what it does is we send the waste, the sludge through this system. What it does is it's got two belts that snake through the rollers, and as they're doing it, they're squeezing the water out. The water is kind of being collected, sent back to the plant for treatment, but then the solids, what's left, comes out the outer end here, and it's been dewatered is what we call it. And it's kind of like something between a sand and a toothpaste kind of thing. And then we have an auger that takes that and just dumps it into the truck. And then once a week, I think, or so, whenever we run the press, that fills up. We haul that off and we dump it on this pad where it dries, where it stays, and we can keep it there up to a year. And then what we do is we haul it or make it available to farmers. That becomes fertilizer, which of course nowadays is a pretty valuable item, and then that gets spread on fields. It's perfectly suitable for that. So I just want to show you what the controls look like in the laboratory. Fairly complex electrical controls, complex system to control this. If you look at that little screen on there close up, we literally, it's a touch screen, Ellen Bradley, we literally can touch this and we can go into any operation, make changes, gather data, that kind of thing. The lab looks like this. Obviously, we've got to constantly be taking samples, measuring what's in the wastewater, making sure that we're getting the proper treatment. So with that, I would entertain questions, but once again, that's kind of hard to do in this setting. I did want to thank you for listening, for watching this video. Hopefully it's informative. Some really cool stuff that we get to do here in Dyersville. And again, we've got very talented, skilled, experienced individuals that are involved in running our water system, running our wastewater system. And, you know, if you're a kid watching this and you're wondering what you're going to do with your life, I would strongly consider public works, maybe water, wastewater, maybe streets, you know, any of that. Thank you.